So we're going to look here at two word problems, also known as applications, dealing with the rate of change. That's one thing that slope does. It tells you how much you go up over a certain amount of moving across, how much the numbers go up or down over a certain amount of time. And so we're going to look at this one where we're going to establish that in 1974, that's the year that we're going to use to drive the price of a stamp. A stamp was 10 cents to send a letter across the country. And by 2009, the stamp cost you 44 cents. So what we have is two ordered pairs. If you put in 1974 as the year, you'll find that the price was 0.10. That's 10 cents or 10 hundredths of a dollar. The other one that we have is 2009 is the year. And by then a stamp was costing you 44 cents. In 2009, we actually had our 44th president as well. I'm just remembering that now. Anyway, we want to find out the rate of change. The slope is the rate of change. So what I want to do here is I want to connect my y's of my 0.10 to 0.44, both above the 0 and both go. So what's happening is the years are going from 1974 up to 2009, and the price of the stamp's going up from 10 cents to 44 cents. So what happens is this is what I would have to do is add 34 cents. I have to make this go higher by 34 cents. And this down here, to get all the way up to what I need there, I actually have to go up by 35 years. And so then I'm going to find for this that the slope is equal to, I'm going to keep the 0.34, that's 34 cents, $0.34, because there's a dollar sign waiting here for my answer. And I know that this is up by 35. So what I really have to do is after I've made that decision, if you're wondering how I got it, you can take 44 cents and lose the original 10 with subtraction. There's 34 cents. Take the 2009, subtract the first 1,974 years, and you've got 35 years left. I've got that fraction that includes a decimal, and I want to kick in my calculator because I want this to take me to 3 decimal places. Actually, I want to show 3 decimal places and round off that 4th one. See what I come up with. So I want to look at 3 decimal places when I'm all done. So I'm going to go in here and I'm going to put in what this asks of me, which is going to be that I'm going to put in 0.34, and I'm going to do division, and I'm going to divide it by the number 35 as the whole number, and I get this, 0.00971. So this equals approximately 0.00971. Now I actually didn't need the 1 because we've looked at rounding before. And what happens, let's see, is that point? Yeah, 0.00971. Okay, so what we're finding here is we've got to go to this decimal place is the last one I'm going to write. And that means I don't need the 1 because that's not going to change anything. But I'm looking at 97 and deciding whether that's more like 90 or more like 100. And it is more like 100. So what's going to happen is when I round that off, I'm going to get 0.0, and the 97 now begins to look like 100. And now that's going to be dropping off that 0, and I'm going to get 0.010. So that tells me that we looked past the fact that it was a penny, but it goes up about a penny per year. So what we're going to say is because it's positive, it's going to go up, and it's going to go up by 0.01. And then we need the 3rd digit that they asked for, and that's about 1 cent per year. So each year it goes up. In this time frame, it went up by a penny. So that's the cost of postage and how we got the rate of change. It's a change in Y, which is our price, over the change in X, which is our years. We have a very similar problem here from 1975 to 2000, so kind of the same era. There were 152, this is speaking of thousands, females in prison. So there were 152,000 females in prison at that point. And by 2000, there were 1,002,000. That's not 1,000 plus 2,000. That is 1,002,000 women in prison. Find the rate of change. In other words, on average, each year the prison population, choose one, increased or decreased by how many thousand women? So what we have in this case is, I'll just block it off here. There'll be enough room for me to do the work. In 1975, we had 152. The second year that we looked at was 2000, and we had 1,002. We're going to connect our Y's on top, connect our X's on the bottom. 1975 plus 25 will get me there. excuse me. Over here I got 1,002 minus 152. So that's going to be a 0, but this I got to turn into 9 and 10. That's 5, 850. So up here we have 850,000 more women. We call it 850 for the work we're doing on this problem, but 850,000 more women were in prison by the end of this time. And we divide that across the 25 years, so we've got M is equal to 850 over 25. You can do that with long division. Certainly not necessary. You can do it with any calculator you have, just like the one I have right here. Or at least I had it here. Okay, so I'm going to clear what we had. And I'm going to take our 850. We're looking for the decimal that it might generate for us. And we're going to divide that, 850 by 25. The number we come up with here is 34. Exactly. So if that's the way the numbers worked out, then this would be 34,000 women. So as far as women in prison go, between 1975 and 2000, the prison population each year on average grew by 34,000 women. If you were in my Math for Liberal Arts class, I'd let you have the opportunity to do a project on that, so maybe you'll take that in a year or so. But that course, we look at numbers and how they affect things that go on in society, and we would even look at what does that mean, what looks like is the cause of what's going on with that. And I've had people do this project in the past, and they go in thinking about whether women are just starting to misbehave or whether the population is growing so crazily or what's going on, and they've come up with different conclusions based on the numbers that they found out. It's very interesting to me what people do when they come up with that. But this is what we do when we find a slope. Talk to you soon.